So I'm going to talk a little bit about my experience 3 years ago with what we went with the Wood Solutions Group, a team of us who went to see timber construction in North America, and okay, even my screen's a bit slow, I'm sorry. Right, this is the journey that we took, mainly to the northwest part of America. That triangle area, the Golden Triangle, is the tour that we did. But in my journey there, I also went to Los Angeles to catch up with my compatriots over there, and had a look at a lot of different styles of timber construction around the Californian region as well. And then after the Wood Solutions tour, we also went to Minneapolis and had a look at a lot of the construction over there at the same time. The three areas that we went to had a lot of seismic activity as well, so the designs were governed in many aspects by that. And up in the northern side, particularly the Washington side, there's an immense amount of Douglas fir plantation and so on. So Douglas fir and so on is very commonly used over there. And SPF is the most common framing species for all other timber 4x2 framing styles anyway. But the US has enjoys a large range of timber species that are available, lodgepole pine and other things like that. And we don't have the same sort of species. Ours over here in Australia are predominantly radiata pine and a few other related species. But anyway, so I'll cover what we saw and what we learned during this experience. And in this talk, I'll cover the different types of construction timber that we use, the different forms, the different types of timber materials that there are and that we saw, and the engineered wood products that are utilized in constructing these timber buildings. I'll start off with the pretty ones. The heavy mass timber construction is always very impressive. These are commonly used in a lot of commercial buildings. The warmth of the timber compared with, say, cold steel or concrete appeals to people of natural, a natural sort of affinity towards touching timber. People will touch timber, they won't touch concrete or steel in the same way, but they will hug a timber post quite readily. Now, CLT is very well advanced over there. They had a whole lot of CNC machines that does a lot of these cutting, ready routed beams that are basically assembled on site, very much like a jigsaw mechano set. And a lot of connections are readily available as well for a lot of these projects, a lot of which are concealed, but not in this particular example. But yeah, there are a lot of commercially available ones which are concealed connections and so on as well. But the material that they do have over there that we don't have here in terms of engineered wood products, that was of course a glue lamp that we saw. Although we have got LVLs and as well, something we don't have here is parallel strand lumber, and this is an immensely wonderful product that they have over there. It is like harder than hardwood. It's just a very, very strong, very, very rigid material, but they take advantage of this material over there, which would be nice if it were introduced in Australia. Another popular form of timber construction material is CLT, and that's taken up in Australia in great forms, as Dean mentioned, where he's working in King Street. And we saw some really beautiful buildings in CLT construction and so on. And really, when you have the glue lam and the CLT construction, you want to expose them as much as you can, because they are a real asset to a building in terms of the materials and the aesthetics that it offers over alternative materials. And the beauty of building in timber like this is that it tends to be fairly quiet and less intrusive on the neighborhood. It tends to be cleaner on the environment around it, as well as a much more as green credentials in the way we produce the material. So a lot of advantages in using timber over alternative materials. And in less conspicuous means, there was a lot of nail laminated timber panel being used as well. Nail laminated solid panels are basically just simple 4x2s, or 90x35s or 90x45s, whatever it is. Just one plank at a time, or one board at a time, or one stick at a time, just nailed to the next stick until it becomes a solid panel. And these are excellent for unidirectional action as a panel form, because it spans and carries good compression loads, carries very good face loads as well, bending strength in one direction. And they use it in a lot of different applications. Like this one, I think, was in a lift shaft to create a solid core. There was a lot of research we saw at the University of British Columbia with FP Innovation, looking at timber concrete composite sections as well, utilizing the best of different materials to create new systems of construction. And this is something that MiTek has also taken on board to do some research here in Australia. And in fact, we have successfully done some research for the last year or two. I've spoke about this at the PTEC conference. And we have our first project now, an actual job now going ahead in Western Australia, coming off the ground probably in a month's time. So it's all been submitted for approval, and everything's going smoothly. And we look forward to using that. The advantage of wanting something like this is often in the energy efficiency, having enough thermal mass in the building to gain the 6-star or more rating. But by far, the most construction form we saw was using lightweight timber stick frame construction. This was the very first building we saw in Los Angeles. This wasn't even part of our formal itinerary, but just driving around the area, we see smack dab. It's there. It's being used in timber is being used in constructing mid-rise very, very commonly over there. But in terms of a 6-story, it is typically stick frame because it is the most cost-efficient and the most effective way of building a functional utility building like this, as well as some very nice decorative buildings. But it's not the same razzmatazz or star quality as glulam, mass timber, or CLT. But it is very effective for building up to 6 stories there very typically. So the first lesson we really learned going there is that using timber in mid-rise construction is very, very common. It is common practice. In fact, when a lot of people we encountered over there asked us what we are there for, we said we are there to learn about mid-rise timber construction. They said, "What do you mean? I mean, there's nothing to learn. It's been around for so long, hasn't it? But to us, it's new. But to them, it is very old hat. It is very commonplace, very easy to accomplish." So, how do they brace these buildings? The first thing you'll note when you look at all their buildings is that they've got very few very few walls. Most of it's all openings, as you can imagine. And that's the sort of things we do encounter. So we have to deal with the fact that there's not necessarily a lot of walls to brace with, and having to be able to accomplish that is a challenge. In the first building, I noticed, I showed you earlier, we saw the use of trusses as bracing panels in walls, and that's one way of accomplishing it. But by and far, the most common way of accomplishing bracing over there is to encase the whole building with plywood or OSB. And this, in conjunction with a whole lot of tie rods and other systems, creates a very nice little eggshell for the structure, a nice little shoebox, if you like. And that's the most common way of doing it over there. And as you can see, like Dean's building in King Street, there's quite commonly a concrete podium below that allows for different functions of facilities to be incorporated downstairs, anything from car parking to commercial activities. And internally, there's a lot of plywood OSB shear walls as well to contribute to the overall shear performance for the buildings. That's part of the shear wall bracing. And they utilize a lot of expansion gaps between the sheets to accommodate any take-up of different movements and expansions or whatever. Apart from shear walls, shear panels, you have to have decent diaphragms. And the floor diaphragm is something we see quite categorically over there, done with OSB or plywood in some cases, but predominantly OSB. Our normal particle board, chipboard, is not really a structural material. It's good for domestic construction, but when you're talking about large commercial structures where you want a dedicated diaphragm, you really should be looking at a dedicated structural product. And any structural ply or sheathing material is a good form to use. But over there, OSB is very, very common to be used as a structural floor diaphragm. And naturally over there, they cover the whole roof in the same OSB to provide a structural roof diaphragm to encompass the whole structure and thereby create that eggshell shoebox effect that I talked about. In some cases, like in this building at the bottom right, you can see it's actually a brick building. They are not afraid of hybridizing with different materials like steel bracing if necessary, because you get the advantages of different materials. But they're not going to do a whole building in steel either, because there's so much advantage that timber can offer. And that's why they hybridize timber into this building that's braced in steel. So timber doesn't always have to act on its own. It can act with a concrete podium below in a hybrid form, or it can act with steel where it's appropriate. And I think we've got to be open-minded to use the best material for the best purpose in wherever we can. So that's another bracing system. Walls. What do we see over there by way of walls that we build? As I say, I'm emphasizing on light timber frame construction. One thing we notice that they're not afraid of using deeper sections. 140 deep studs is very, very common over there, and they will put it wherever that's needed. So, so if it needs to be done, just do it, and it's very, very effective. They're not afraid of using double studs either. As you go up 6th story, that's quite a lot of compression load coming down. There's a lot of double studs being used everywhere that we see where it's appropriate. And there's a lot of party walls as well. A lot of these are residential apartments, as you can imagine, and so on. So there's a lot of separation walls for noise and other reasons. So we see all sorts of practices. We see this staggered studs with single top and bottom plates, wider top bottom plates to create that separation between the occupancies. But probably more commonly, we see twin separation walls, like we see over here, to separate all the different compartments and apartments. And double studded twin separation walls as well. Anything. They use them more. And in terms of the wall, the floor systems, floor structures, we see a lot of floor trusses being used in different parts. But over there, perhaps more commonly, would be I-joists. They have a lot of EWP I-joists over there. Floor truss is one wood product, engineered wood product. This is another engineered wood product, and that's very common. And they use a lot of top hung hangers over there to suspend all the joists and beams. As you can see from here, a big LVL beam there to carry a heavier wall load from above. So these are very, very commonly seen to form all the floor structures. In one or two occasions, we see them using glue as well to sort of enhance the reduction, to reduce the amount of squeaking or potential rubbing or contact and movement between different materials to reduce noise and sound. So not a bad idea, useful little idea, something that we see being done over there. And you can see the parallel lamb over there, the PSL, parallel strand lumber, excellent materials that you use plenty of. And because there's a lot of compression load coming from the upper story walls as well to transfer through down to the lower story, they use a lot of solid blocking between the floor joists to transfer the upper wall loads down to the lower walls right through the whole system. A very common, simple way of transferring forces through the building down the stories. We did see a few occasions where they even use concrete topping for the reasons that they want, whether it's for thermal mass or for sound improvements. it is a good way of achieving what you want to achieve with different materials. So yeah, this they often pour up against a double top plate, double bottom plate that they might form with enough depth to form as a permanent formwork for the slab. Balconies were a common formation. We've seen different types of balconies readily being formed with timber as well. As you can see, some large panel at the roof level there, but also a lot of CLT panels down below to form the balconies. That's readily done and really accomplished. And again, there's a lot of canvas panels with even timber framing and with using some steel beams if necessary, where it accomplishes the kind of connections that they need, or the strength, or the distance that it reaches for the depth and everything that we work to, the efficiency it provides. They take advantage of whatever is available. And in this particular closer up, you can see how it's anchored back again into a timber structure. So it's predominantly designed in timber, but wherever necessary, it would also encompass some timber structural steel components to enhance the whole project. So people thinking and working and taking advantage of what we've got. But there's a lot of cantilever timber balconies as well, and they often reverse the hangers as well into different directions, up and down, depending whether they want to take uplift or down direction, to transfer the load from a perimeter beam back into the building. There's a lot of connections and ties being used. We see a lot of drag strips over there being used, whether it's wrapped around the perimeter edges, as you see from the top, down below into the blocking, to tie in the perimeter building back into the primary structure. They do that a lot of, in a lot of cases, right around the building. And a lot of them are also tied back then to shear walls, and to provide a lot of continuity, depending on how the bracing system in this building is done. They enhance it by way of additional drag strips to make sure that the forces are transferred in its entirety to the main shear walls. If you were using, for example, a block concrete stairwell core, you want to make sure everything's tied back to that wall. There was a lot of horizontal shear connections of the different stories as well. We did see, like in this case, they did fix from the OSB panel to the OSB panel. And in some cases, they were fixed from the blocking down to the top plate level in a hidden fashion over the top of the top plate. As you can see, a small detail from above on the top left-hand side of the screen. They would readily fix these to provide lateral shear transfer to transfer down to the lower shear wall. So the forces are quite big. A couple of skew nails on the to fix the truss down, say, to the top plate is not enough to transfer the shear forces. They want full transfer of the forces from the upper diaphragm, floor diaphragm, down to the lower shear walls. A lot of boundary beams and joists would be fixed for the same reasons, using all these horizontal shear connectors to make sure that you have the full shear transfer from floor to floor to floor, from floor to shear wall, and down the 6 stories. Yep, a lot of tie-down strap. Naturally, you want to be able to make sure everything's tied and connected and wrapped. There's a lot of tie-down straps like these being used, and there are a lot of whole full-length rods that ties right from the concrete podium or concrete slab below right up to the very top of the roof, with spliced rods that go up to about 3 inches. I've seen 3 inches rod being used and being used over there. 75 mil rods, huge rods down to small rods like this, 16 or 20 mil. And they have different systems for splicing, like the nuts on the right to splice. And there's often a little round inspection hole, like you can see on the top left there, a little round inspection hole to make sure that that's enough threaded bite onto both sides of the rods to make sure you don't have too much on one side or the other side. And a lot of chaser nuts or cinch nuts, as you can see in the middle, that take up any movement permanently. In the example on the left, those type of cinch nuts, they usually load the building down, finish a building, and then they come back over here and they press a spring which would then activate the ratchet action over there. So you can't activate that too soon. You want to activate that late until so that it has enough residual movement to take account of future depression, movement from shrinkage, compression, live load, say dynamic activity, anything that compresses. It will then take it up and keep on locking the building down as it goes. So it's continuously self-tightening. The one in the middle, the cinch out, is also self-tightening, except that one you don't have to initiate it. The minute it's used, it has a continuous action, has got no limit as to how far the ratchet action will go. So yeah, some of the different systems they use and are being used over here. And these are also readily available. And there's a big project with this in Mary Potter, I think, in Wellington in New Zealand, taking place right now. Right. There's a lot of panelized construction. We can see over here, they set up a crane on the right there. And a lot of these panels are then lifted, panelized walls and panelized floors. Over there, they often set up a flat area, concrete area somewhere nearby that they, in fact, do a lot of panelized pre-assembly on site and then lift them themselves. Over here in Australia, it's predominantly done in a factory. We have a lot of dedicated factories over here that do a lot of panelized work, invested a lot of machinery to be able to do all that so that it's all ready to be delivered on site and lifted. And that's going very, very successfully here and being taken up very nicely. But panelized is where it minimizes the disruption to the community, disruption helps with the cleanliness issue and reduces the amount of waste. It's a very good way of rebuilding a community without disrupting the neighborhood. For them, lifting prime panel system is very, very simple. A person on the right there, as you can see, would just simply saw cut a square hole on the panel, and they will wrap a chain around it to lift. They're very straightforward like this. They'll just do it and lift it. And sorry, I should go back up a bit. And as you can see it on the top right-hand side there, after he cuts the panel, he would tack the panel next to the hole because they would come back later after it's been lifted to reinstate that panel to fill up that hole again. That's how they do it over there. We see a lot of webbing straps here being wrapped around the studs and plates and then nailed to the frame for lifting the frames. They use lifting slings like these, which is something we haven't done over here. And they use a lot of panelized lift shafts as well. We've done a few projects here with Timber Truss and Mervac over here in Doncaster. I think it's a lot of 3-4 story plywood lift shafts pre-assembled and installed. So yeah, lots of different ways. Fire features. We saw different fire features over there being incorporated. The things that we've talked about over here. They have a fire-rated OSB. One of the concerns, naturally, is the building catching fire during construction, and they have a fire-rated OSB for that purpose. It's something that we have to deal with to try and create sometimes a necessary border or fence line around our buildings to make sure that nobody sets an unnecessary fire hazard towards the building while it's undergoing construction stages. But you can use different fire-rated materials, although that's not so commonly available over here. There are fire-rated I-beam hanger systems available as well for fire partitions and firewalls. This one here by USB is one that they actually is a structurally approved one. They actually hang this floor system on the top wall, and it's got a little gap with a blade between the shoe and the wall. And this allows 2 layers of 16 mil fire check or whatever fire check to slip up behind the joist and rip its way, cut its way into the board as it goes through, so that the board would then go wrap around naturally around that little blade. So a clever little way of doing things, but they have a fire-rated system that you can just slip up the fireboard, fire check, or whatever it is behind the joist. And that provides the fire compartment. and that can be available here as well. It's something that's yet to come in. So there's obviously a lot of gaps between the party walls that are eventually filled in to have the fire block. In this particular case, I took a photo without that having been filled yet, but that part has to be done. They also utilize a number of ducting cavities where they actually fire line them as well. For whatever purposes, that maybe these areas have got some sort of downlights and other things like that. I don't know, but or at very least maybe the ventilation vents to come down through those areas, and so they provide some protection around those areas as well. That's a very good idea too. So just in closing, some other light miscellaneous details of things that I did see over there. To take account of settlement, building settlements and movement potentially of coming down across the 6 stories. The plumbing, they often have a lot of bends here and there to try and take up any future movement of the building, although there shouldn't be a lot. But if you provide them by way of different bends and returns, they are much more flexible than a straight, long, uninterrupted shaft. So that's the way they deal with them. They do work with some limitations, but they're really the services is not an issue. They're not. Once you get into the scheme of things, it's not really hard to do. So you just provide a number of bends to deal with those sort of things. They do use a lot of little cable protection plates to make sure that the occupants in those tenancies don't accidentally drill into the cable wires and behind there by having a steel plate to alert them that the fact that there's something underneath that you shouldn't go beyond. So good way of protecting. This is just something of interest. They've got a scaffolding system there that I haven't seen over here being used before, but yeah, that's what they have, and using in all sorts of buildings like this one here. Very commonplace. I can't show you all the buildings we saw. It's just too many. But in closing, just have to show you the spectacular Brox Commons building we saw over there. 18-story or so, yeah, a complete timber building, a beautiful building. Just sensational what the tall timber buildings are being done right now all over the world. We need to get there ourselves. So thank you all. Appreciate your listening.
Right, thank you, Robert, for that very informative presentation. I was also fortunate to travel over to North America, to Texas and California a couple of years ago, and similar to what Robert said, you know, I was very interested in going around having a look at what they refer to as their multi-family construction, and my colleagues over there were saying, why are you looking at these buildings? They're so common. You know, there's nothing special about it. But for here in Australia, it was something new, and it's great to see that a lot more interest in timber buildings happening now in Australia. Okay, so we've got some questions here that have been posted. Robert, I don't know if you had a look at the Q&A tab, but I'll read through these. So Jerry's posted here, Robert, would welcome your experience in New Zealand and in the US in dealing with weatherproofing and waterproofing of balconies in lightweight multi-unit timber frame construction. This issue has been at the forefront in building defects in Australia and New Zealand. So Robert.
You want some insight on waterproofing? That's a very good question. I must admit, I'm not a specialist on those sort of features particularly. I'm more on the structural side, but nothing from what I've seen has been a major issue in waterproofing. There are a lot of waterproofing membranes that I saw being used, and it's more perhaps in the way some of the details are done. But I must admit, I'll share that that's not my forte. I wouldn't dare to be the person to advise how that's being done. So I apologize. That's not my forte. But if somebody online is, I'd be very interested to hear from them.
Yeah, and certainly, you know, would be happy to meet with Jerry and talk about some of the different waterproofing issues that may be out there and the various ways. I will point out that in Melbourne at Homesman TAFE, we do have a demonstration building, a 3-story model based on a 7-story building, and that has some waterproofing details in there for balcony top situations as well. So yeah, Jerry, if you'd like to get in touch with the team at a later date, we can certainly talk to you about that. The next question down from Gerald, I noticed a lack of noggings in walls that appeared to be approximately 3 meters high.
Yes, you're right. That is one of the things that we did observe quite markedly. They do not use nogs extensively. Perhaps that's why they have a 140 nogs as much as they do over there as well. Like in the Australian rules, we do often rely on the nogging primarily for stabilizing the studs during the construction only. Hang on, maybe I'll see if I can turn my camera on. I can't even see my mouse for some reason. Anyway, look, during construction stages, the nogs would help to certainly to provide the lateral stability. But once you install, once you fix the OSB and other linings on, the reliance upon the nogging is almost non-existent. It is no longer really a big issue. It is only during construction loads. So when you talk about loads, the construction period is usually only a matter of a few months, say. So the duration of load you're talking about is only a few months, say 5 months. And so your duration of load factor is somewhere in the order of 0.9, you know what I mean? So it's quite high. In other words, you don't have to be overly sensitive about buckling when the loads are only for a few month period. It's only a long-term duration that you're more concerned about. And by that time, you will have your full lining on. So I think that's the way they've relied upon it over there, and don't rely on the nogging in the long studs.
Probably also because they're sheathing everything in plywood or OSB, that sheathing is going on very quickly. So the studs are not sitting there on their own for a long period of time, and there's probably no load above and before the OSB goes on.
Absolutely.
Yep. The next question down is, how would you say lightweight mid-rise solutions uptake compares to the level in the USA? Are they similar points of market development, and depending on answer, why? And how do we increase the uptake of lightweight timber solutions for mid-rise in Australia?
Sorry, can you repeat the question again? I can't seem to get the real question loud myself. Yeah.
Yeah, certainly. It's, how would you say lightweight mid-rise solutions uptake compares to the level in the USA?
Oh, look, it is very, very common, immensely common. And that's not just because we were deliberately taken around to have a look at some of these buildings as a targeted tour. Speaking to my colleagues over there and just doing a general drive around the whole community, you can identify quite categorically that there are lightweight timber structures that go up to about 6 stories very commonly over there. That's because it is very commonly available timber size and gauge. It doesn't require a lot of specialized materials. Doesn't require a lot of particular preparation. It is readily and widely available and very cost effective. That's the point about it. It's very, very cost effective. And just panelizing them and lifting them makes them very, very quick to install and put together with a lot of simple nails and bolts and so on, without going to a lot of complex connections as well. So that's the beauty about it, and encasing it in an eggshell OSB. It's just very cost effective and just functional. So predominant, I'd say, when it comes to that. It all depends on the use of the building, actually. As I say, if you're looking at a high-end architectural building where you want exposed timber, certainly the mass timber and CLTs are it's a perfect way of going there. Or if you need high compression or much higher buildings, or bigger spans, extremely big spans, these are ideal for, as Dean said, for multi-tenancies, multi-residentials, and so on, multi-family. They're beautiful because the compartments aren't that huge. But if you're talking about big spans, huge, yeah, sure, you look at something quite different.
Yeah, I'd like to add to that as well. I think in America, North America, they've been doing this type of construction for a number of years, whereas in Australia, the NCC only introduced deemed satisfied requirements back in 2016. So it's relatively new for the Australian market. So yeah, it's certainly a growing interest here in Australia, but we've got a long way to catch up to America for that multi-family type construction. It is just so common over there. Next question down, Robert. Is the parallel strand lumber the same as the scrimber product that was marketed in Australia some 20 years ago? It looks very similar.
Yeah, it is a very, very similar sort of product. Basically, what they have is that big wood fibers, larger chunks of wood fibers, are all in the process, in the manufacturing process, all aligned in a unified direction. And it's the form of the fibers that's used that distinguish it between parallel lumber and scrimber and so on. It's a bit of a formulation and so on, and they also call it by slightly different names. But yeah, ultimately the same sort of concept is used in the scrimber as well as in the parallel, and that's why you get very, very high strength with those. Correct.
Another question here from Polo. What are the typical performances and optimal uses of the different wall bracing systems that you showed?
What are the
typical performances and optimal uses?
Okay, bracing system. Okay. Now the truss system with the metal webs are fairly light. They wouldn't provide the greatest forces. The plywood would be the most common because it's highly rigid and highly stiff. So you'll see the truss one, for example, at the very top story where it's a lighter performance. You wouldn't see that in the lower story. Plywood was very common because it's just very easy to work around the whole building, create a constant cover over there. In terms of the structural steel, very rare do we see structural steel bracing. It's only for very specific purpose if they have certain criteria to meet, such as in that particular brick building, which was designed to be in a brick clad, that they need a certain ductility or rigidity as the matter may be, that was done in that fashion. What else what other bracing system did I encounter over there? I think those were the three I talked about.
Yeah. I think it's also fair to say that or particularly in the US, the bracing system they use, the calculations are a little bit more comprehensive. Like in Australia, we use A1684 for residential construction, and it's very basic type calculations, whereas they go into a lot more detail on distribution of forces and everything like that through the different bracing walls over there.
Actually, I tell a lie. Something I didn't put into the system and into this presentation is that hardy frame over there, there's a whole lot of metal inserts that they do, metal shear wall insert that they do into timber frame buildings. I should have put that into here actually, but I was so focused on all timber, I forgot to put that in. But there are a number of shear panels, steel shear panels that they insert between studs over there, or different panels, and they're very, very high strength, very, very effective. But they do rely on very massive anchorage, and the way they accomplish those anchorage is to have big mass concrete at the ground level, and I mean mass, a couple of meters of concrete, and they have big rods that tie them to give them the full rigidity. We have not come to that stage over there, but it's totally achievable here, but it's just not popular here at this point in time. But yes, there's also that system that goes with light timber frame.
Yeah. Thanks, Robert. And the next question, what level of prefabrication do you see in the US? I've heard it's mostly stick framed on site, but here we seem to be more interested in panelized systems.
Oh, well, I mean, stick. When I say stick frame, none of these walls are actually stick frame literally as a stick by stick. All of them come as panels, whether it's pre-nail panels or panelized nail panels. The only distinction is that they don't necessarily do all of this from a factory. Some of them will actually have a dedicated area on the side where they have another crew, because the Mexican labor there is quite cheap, apparently. And they will have a lot of people nearby assembling the panels nearby before it's all lifted by crane or by other means onto the building. So none of these walls would actually be physically formed on their floor levels, no.
Yeah, I think that's right. In the more standalone house residential construction over there, there's a fair bit of stick frame, again, because of the cost of labour. But when you're putting a building of this scale together, speed of construction is very important. And I think that's why panelised systems in Australia are so key, is that you want to have the fewer people on site, and the really speed of construction is a major benefit. Next question down is, what is the material used on the facade?
materials used on the facade. I'm not sure which particular facade you're referring to. Dean, what do you think?
Yeah, I guess it really depends on the building. They do have a range of different materials over there that they use for the facades. Yeah, so yeah, like in 25 King Street where I am, you know, it's all glass. Over there, they might have more panelised type facade systems. So yeah, there's quite a wide range of different facades available.
Not the polystyrene sandwich panel, if that's what you're asking.
That's right. Another question here, do they have particularly high lateral earthquake loads?
Where we visited, yes, we did Los Angeles, as you can imagine, up towards Washington and Minnesota, Minneapolis over there. They're all very high earthquake regions, which is why these rods are very cleverly designed. And although you normally expect to see a larger diameter rod on the ground level tapering up to a smaller rod at the upper levels, it is not necessarily the case. For the dynamics, it can actually be reverse direction as well, depending on how much movement they want to restrict at different levels. And they sometimes even use high tensile rods for that purpose. But yeah, no, there's a lot of dedicated systems, and we have also seen some hybrid steel frames as well for mainly retrofitting some buildings to provide the seismic resistance in the lower story. But generally, the plywood and everything is quite capable of dealing with all the seismic action with those tie-down rods that we've seen.
Yeah, I think timber performs very well in seismic applications because of there's so many connections that it makes it quite a ductile type solution. There's been a bit of swapping and changing of order here because as people are going in and upvoting, so I'll just scroll through. I did see one from Craig, but I've lost it now, about oh yeah, here we go. Did you see any mid-ply shear walls on your site visits?
What shear walls?
Mid-ply, so that's where they use a truss system and then have the plywood or the OSB with the truss.
Oh, I see. No, actually, I did not see that during my travels. Good question, but no, I haven't.
Another one from Craig here. Are the buildings progressively coated with water-repelling compounds during the construction period? I.e., could the timber could be exposed for several months while being constructed?
No, having said that, I believe the applies, the OSBs do have a natural, not say natural, they do provide a bit of a water repellent coating on all the OSBs. So that is very common over there. They do have a water repellent, and you can see that when, in some occasion, you can see when it does get wet, it doesn't absorb the moisture. You can see that the moisture retains on the surface in a small droplet. So yeah, they do use that coating, but they don't have to reapply that constantly over the 5-month period. No.
And I guess depending on the areas over there, like there are parts of the US where they don't get a great deal of rainfall, so they've got quite a lengthy period of time that they can go for construction. Okay, just going through the list again. Oh, Brett's made a comment here. Thank you. Yes, to no noggings, and I see that there was another comment about noggings from Len. In response to the use of noggings in Australia, the US building practice has been for claddings fixed to both sides of the sides. Most of their bracing is also OSB to the total wall frame. In Australia, where brick veneer is commonly used with plasterboard only to the inner face, noggings are required to provide the long-term stability. So yeah, thank you, Len, for adding that comment. Do you see much shortening in lightweight buildings? How can we minimise this, and what is the impact on the structural design?
How to prevent lightweight shortening in lightweight construction?
Yes.
Reduce the load. No. Seriously. Okay, there are three contributors to shortening. Obviously, one is timber shrinkage. If you close in your building early and keep it dry, the sooner the better, because then your timber would not shrink as it dries. So if your timber is nice and dry when it's all closed in, obviously that helps, and naturally it should be anyway, as it should be. Shrinkage is one. Creep is the other, and creep is often related to shrinkage as well. And that might take its time, but that's something you have to deal with. And then compression. Obviously, as you press down on all the beams and blocks and studs and everything does come down and will move. But a lot of it actually happens early and the later ones would be when you start moving in furnishing and other things and start loading the live load and so on. Okay, naturally. The fourth one I didn't quite mention. Yeah, as the building rotates and as the building, not say rotates, shears and wind or moves or what for whatever reason, of course there'll be an uptake of the movement and the building might come down as things compress. So the key idea obviously is to tie down with this locking system that will continuously lock the building down, and so that doesn't continuously create a slackness into the structure. The other thing is that you'll notice I put in one picture only of a gap. They do introduce a lot of gaps in between sheathing and sometimes even within the floorboards. They try and create some gaps so that it takes up some of the movement and shrinkage as well, so they don't have unnecessary contact. And there was one more thing I was going to say. I slipped mine now because I've been talking so much.
Yeah. I guess we're mainly focused on the timber construction side as well, but even the plumbing and things like that, they do have connections that allow for the movement to occur as well. So that's
thank you, Dean. That was what I was thinking of. Yeah.
Okay. What systems do they use to combat institutional condensation in these types of buildings? Vapor permeable wraps, rain screening systems.
I missed the question. Sorry.
It's moved on me now. It was about condensation. Do they use vapor permeable wraps?
Oh, I see. Yes, I think in some of the buildings pictures we did show you that the little yellow wrap that they had. Yes, there are wraps that they do use for some of the protection as well. That's true. Yep. And
what was the concrete topping shown in one of the slides? Was that non-structural only?
Yes, it was purely non-structural for, we were told, I think, for acoustic reasons more than anything for that one.
Mm-hmm. What sort of lifespan of these buildings and what sort of cost of timber?
Oh, gosh, that would definitely vary from country to country and region to region. Lifespan, well, look, these buildings last for quite long decades. There are examples of these for, I can't remember how long they've been, but yeah, 50 years I think would be it's a standard approach to designing this sort of structures. So I would expect these buildings to last more than 50 years, definitely.
Mm. Yeah, I think for any well, not only a timber building, any building at all, you've got to design durability into it, and to get the lifespan that you expect. And you look at some of the old timber structures in Japan and over in Europe, and they've been around for hundreds of years. So if they're designed correctly, maintained correctly, you'll certainly get the lifespan out of it.
I'd have to agree with that. I think buildings fail not generally because of a big typhoon or earthquake, although that happens. Most building fails because of water ingress, leak, other water damage. You're right. I think that's one of the fundamental things to ensure the longevity of a timber building.
Mm-hmm. Question here from Victor. The fire-rated OSB is quite interesting. Is there a similar wood sheathing in Australia and New Zealand available or currently being studied?
Dean, maybe you can answer that question better than I can.
That's a good question. I'll have to look into that one.
Yeah, no, I must admit, I don't believe it is commonly available here yet, but I can't swear by that.
Mm. One from Lynn, again, going back to the concrete. Does the concrete topping need extra formwork support, or just the floor studs would do the job?
No, they use the bottom plate. The concrete topping is only quite thin. Those are non-structural concrete topping. As I say, they were predominantly lightweight concrete, and in some cases with those little polystyrene thing or whatever they use anyway. But these were non-structural. The ones that I showed you on research at the University of British Columbia, they are structural. They would be quite different. They would require some formwork, and they would require propping and other things like that for construction purposes. But the one that was done with the light topping is only very thin, not very thick at all, and they were just formed on the sides with the bottom plates, and they don't use propping for on the underfloor for those loads. No.
Yep. Okay. Probably got time for a couple more questions, and then we'll have to wrap it up. So Jerry's asked here, Robert, I've noticed they used a lot of flat plate connectors rather than gang nail. Why so?
Flat plate connectors instead of gang nail. Well, when you say gang nail, I mean there would be nail plates for roof trusses and floor trusses, and you can see the gang nail and floor trusses. The flat plate, when you're talking about flat plate, I think you're talking about a connector from timber to timber connections.
Probably the shear plate that you showed, yeah.
Yeah, the shear plates and so on, isn't it? Yeah. Yeah, it's a design of the manufacturer of the shear plates. It looks like a flattened form of what do you call it, or triple grip or something like multi grip, doesn't it? And the reason why they are looking so toothed, when it's basically a nail-on plate, like a drag strip, if like a nail-on plate. But just look with all this tooth, it's mainly to reduce the amount of steel in the connector, because you don't need all the steel above the at the top in between holes anyway, so you can actually scallop the steel around the holes and then nest the way you produce them, so that you have least amount of steel per bracket. That's the only reason why they look the way they did. Otherwise, it's basically a nail-on plate type of product, really.
Yep. And I think we might make this one the last question. And if anybody does have any further questions, please feel free to reach out to the Mid-Rise Advisory Program. And if there's any specific for Robert, I can certainly pass that on to him. But the last question here, it looks like there was a lot of PSL. Did you see much LVL?
Well, that's true. I have to admit that's true. I can't answer the reasons for that. It didn't occur to me to ask at the time, but we did see some LVL, but we did see the parallel strand much more commonly. That's because of its extremely high strength, I suppose, and the radio availability. I'm not sure what the cost differences are over there, but I take your point. That's exactly what we did see. But over here in Australia, LVL is a very cost-effective, strong lumber.
Yep. Well, thank you, Robert. We might wrap it up there. So please join with me in thanking Robert for a very informative presentation. So we'll give you a virtual round of applause, and yeah, you can feel free to go into the chat option there. A little bit of a segue through to next week's presentation as well. Robert did talk about the panelisation. I did work closely with Robert in developing the floor cassette system for MiTek. And next week, we're going to be hearing from another one of our partners. So Adam Dawson from Prida will be talking about off-site manufactured lightweight timber framing components for mid-rise. So he'll be talking about the floor cassettes and the wall systems. I'd just like to remind everybody to please go to our website. We have some very good podcasts on there, as well as the In Focus videos. So thank you everybody once again for attending, and thank you Robert for a very informative presentation, and we look forward to seeing you at future webinars.